So here we go. The last of the conic sections is the hyperbola. And the general form of the hyperbola is x squared over a squared minus y squared over b squared equals 1. Notice that this guy cuts the x-axis. And the other one is y squared over b squared minus x squared over a squared equals 1. Now again, I don't care about a and b, because when I look at a squared and b squared, I always look at it in references to x's and y's. So they flip a and b. I don't flip it. To me, this would be x squared over something squared. You know, and then I would notice that this again is going to be distance from center. Whatever is under the y is distance from center. Whatever is under the x is always distance from center. So that way I don't have to have formulas for who's A and who's B and how that stuff works out. So now in this particular instance, the hyperbola center is at 0, 0. And there's something that you do notice about hyperbola versus, it looks a lot like the ellipse, except there's a minus. Right here is a minus in between. And so it cuts the x-axis here, and these are called vertices, just like on the parabola, or on the ellipse. These are vertices. And if you notice, there's a minus sign here. It doesn't cut the y-axis. And the reason why it doesn't cut the y-axis in this instance is if I know if it cuts the y-axis, x equals 0. So I'd have 0 squared over a squared minus y squared over b squared equals 1. Or minus y squared over b squared equals 1. Minus y squared equals b squared. Y squared equals minus b squared. And notice that when I go to take the square root of both sides, okay, so we have that. These are imaginary. So that's why it doesn't cut the y-axis. There are no y-intercepts. Those are imaginary numbers. So how do I know when I have a hyperbola? Well, there's a minus in the middle. And then the next question you would ask, how do I know whether it's this guy which cuts the x-axis or this one that cuts the y-axis, if you notice who has the minus sign. In this case, x has the minus sign. So when you go to perform this process, you're going to get imaginary numbers for the x-intercepts. So that's why it doesn't cut the x-axis, but it does cut the y-axis. Now, if you take a look at how this guy and how you would graph him, what would you need to know? I'd need to know the center. I'd need to know the distance from center. And then I need a way to find this x. And there is a way to find the x that's very easy. Again, same thing here. I need the center. I need the distance from center. And then I'd have to find a way to do the x. And once I had the x, I could plop the graph in. So graphing these guys are going to be very easy. Now, standard form, x minus h squared over a squared minus y minus k squared over b squared equals 1, or y minus k squared over b squared minus x minus h squared over a squared equals 1. And the center is called as h and k. And a and b, as always, like with the ellipse, is the distance between the center and, we could say, the vertex of the hyperbola. So a and b is always the distance from center. The number that's under the y is going to be the distance on the y-axis. The number that's under the x is going to be the distance on the x-axis. That's why I don't care about who's a and who's b. It's distance from center parallel to the axis. In general form, how do I know? Well, I know because x and y are both squared. And that's the ellipse, and that's true of the ellipse, and that's true of the circle. But the difference is that I have one sign minus. So the coefficient of either x squared or y squared is negative. If it were positive, I'd have a circle or I'd have an ellipse. If it were negative, I have a hyperbola. Only difference. Now, by the way, with these things in general form, what you would have to do, quite honestly, what you would have to do is to complete the square like you did with the circle, to put it into standard form. And we don't want to do that. I don't know about you. You might want to do that. I don't want to do that.